Okay, so 4.6 is finding linear approximations. So when it says something about linear approximations, that tells me we are going to want to find a tangent line. And we're going to use the tangent line to approximate. So this problem number 4 down here says that we want the function f of x equals natural log of 1 plus 2x. And we want to find the tangent line when x equals 0, which should probably be a 1 since this says 1.2. But anyway, so this means we're going to use that to approximate what this value is going to be when the x value is 1.2 here. So what I need to do is plug in 0 for my x to find my point. So f of 0 is going to equal the natural log of 1, which if you remember your properties gives you out 0. So we are at the point, we're at the point 0, 0. This graph is going through 0, 0. Okay, and that's my point. Now I also need a slope to get my tangent line. So I'm going to do f prime of x, which when you do a natural log derivative, whatever's after the natural log is in the denominator. And you take the derivative of that denominator and it goes in the numerator. So this is my natural log derivative of this function. And I need the slope when x is 0. So I'm going to do f prime of 0 now. And that's going to give me 2 over 1 plus 0, which is 2. So my tangent line is y minus 0 equals 2 times x minus 0. Now we could simplify this one real fast. This is y equals 2x. And now it says we want to find this value when x is 1.2. So I'm going to come down here and plug in 1.2. So I get y equals 2 times 1.2, which is approximately going to give us the value of this function at 1.2 is going to be approximately 2.4. So that's our approximation. And what I think he should have done was, if you're going to approximate at 1.2, we should have plugged a 1 in there because that's way closer to 1.2 than 0. So this approximation is going to be off quite a bit. So I think he should have said either made this 1, because 1.2 is close to 1, or he might have had a typo and this maybe was supposed to be 0.2. And if it would be 0.2, if you plug a 0 in, you get, I'm sorry, you plug 0.2 in, that would be 0.2 times 2 is 0.4, would be closer approximation to 0. You understand what I'm saying? So I think you probably made a typo, and either that was supposed to be a 1 or this was supposed to just be 0.2, because you want your approximation to be close to that. Okay? Yeah. It'll be an integer value, yes. And then later on, we're going to actually tell whether that 2.4 would be an approximation greater than the actual or less than the actual, but that's not till next unit. Anybody else got anything you want? Hold on here a second. Let me see this real quick. 1 plus 2x equals 2. Yeah, now that I'm looking at this, since he's got this as my function and he's wanting this, he's saying this is 1.2 here. I am thinking he's going to want us to, let's see, that'd be what, 0.1? I'm thinking he wants us, so we should have done this. I think he wants us to do this instead. So I think he wanted us to find out what x value we're plugging in to get 1.2 from this. So I'm going to put that equal to that. That makes a lot more sense. This would be 0.1, which is closer to 0. So let's plug in 0.1 down here. This would make it a way better approximation. So I think we want to get 0.2 here. Okay, so let's do that. To find our x value, since he left this natural log, and this is natural log, we need to find out what x value from this is going to give us that. So he's wanting us to use x as 0.1. So it should be 0.2 would be our approximation, not what I had before. Anybody else got anything? So I might, see, you see how this one up here is different? Let's look at the one above it is different. You see how he's got f of x, and this is x, and this is x? So this one does want x to be 2.9 right here. You would not set this one equal to that because it's the same thing. But down here, he used the natural log on the right, and this is natural log. So that's why we had to do this part. Again, this one up here, this is the x value we're going to do because it's f of x, and they're saying x is this. Now this one is different. It's saying sine theta equals 0.2. But again, this one, you don't have anything to simplify, so this would also be theta. So this one's kind of an outlier. It's a little weirder. Anybody else got anything you want me to go over on 4.6, linear approximation? Yeah. Number 8, I'm going to get a picture of it up here. Let me get my mouse around here so I can move this way. Okay, it says for the tangent line to this function, so here's our function, at x equals 0. All right, we're not going to worry about this. Let's see. It says approximating e to the h. So we're going to let, this is saying let x equal h is what this is. Now, we're not actually going to find h on our calculator because we're not doing anything with an error. So our answer on this one's going to have an h. So we're going to find the approximation when x equals h on this problem. So again, I'm going to use a tangent line, so I got to find a point and a slope. So I need to find the point that goes when x is 0. So I need to find f of 0, which is going to equal e to the 0, which is 1. So my point is 0, 1. And we are using, or we got to use now find the slope of this function. So the slope of e to the x is e to the x. So I need to find my slope when x is 0. So f prime of 0 equals e to the 0, which is also 1. So this is my slope. So my tangent line is y minus 1 equals 1 times x minus 0. I want to find the approximation when x is h. So all I need to do is plug in h. Now we should probably solve this. And so this is my approximation when x is h. So depending on what h is, it's going to change it. It's going to change what we're doing. Okay, so that's all I'm wanting you to do because we do not do any errors where we actually have to find this stuff in AB. That's a BC deal. Anybody else got anything you want? Anybody got anything off 4445? Okay, so we're going to spend the rest of the period for you working on worksheets or watching videos or doing anything else. Anybody at home got any questions on anything? All right, then I'm signing off, and I will see all of you tomorrow on Zoom, I hope. See you later.